In this video we're going to discuss the Pythagorean theorem and how the converse of that theorem can be used to identify what type of triangle we're talking about. Most of you, I'm sure, are familiar with Pythagorean's theorem that says if you have a right triangle, then a squared plus b squared equals c squared when a is a leg, b is a leg, and c is our hypotenuse. The converse is going to reverse that statement and say if c squared equals a squared plus b squared, then the triangle I'm looking at has to be a right triangle. So we're going to check some side lengths of triangles to see if they actually make a right triangle. So our question is, do the following lengths make the sides of a right triangle? Notice that I'm not going to give you a picture. We're going to try and do this just by looking at the numbers. So first we should ask ourselves, does this make a triangle? Well, 5 and 6 are the two smallest sides, which add up to 11, which is bigger than 9, so that makes a triangle. Now what we're going to do is we're going to take the two legs, 5 and 6, and we're going to square them, add them together, and see if it equals 9 squared, because 9 would have to be the hypotenuse if this is a right triangle. If this theorem works, then we know it's a right triangle. So 25 plus 36, is that equal to 81? Well, 25 plus 36 is only equal to 61, so this is not a true statement, which means this is not a right triangle, because if it was, the Pythagorean theorem would have worked, and it didn't. Now in the second example, you'll see why we were approximating our square roots. Our first side is 2, our second side is 2 root 2. So again, root 2 is between the square root of 1 and the square root of 4, so it's probably about 1.4 being multiplied by 2, which is about 2.8. 2 root 3 is also between 1 and root 4, so it's going to be approximately 1.7 times 2, which is about 3.4. Now again, the only reason I'm doing that is so I can see the value of the numbers. Now that I know which are the two smallest sides, 2 and 2 root 2, those are the numbers that I'm going to use in the Pythagorean theorem. So I'm going to ask myself, is 2 squared plus 2 root 2 squared equal to 2 root 3 squared? And you'll notice I'm putting that in parentheses because people forget a lot to square the square root correctly. 2 squared is 4, but 2 root 2 times 2 root 2 would be 4 times 2, which is 8. And then 2 root 3, again, would be 2 root 3 times 2 root 3, which would be 4 root 9, which is like 4 times 3, or 12. So when I simplify all that out, what I'm looking at is 4 plus 8 equals 12. Well, this is true. So since this is true, this has to be a right triangle because the Pythagorean theorem only works when it's a right triangle. So be careful with your square roots. When you're squaring and simplifying, make sure you're doing that correctly. On the third example, I see 4 and 8. Those are easy numbers, but I have to identify what's the biggest side. 4 root 5, let's see, root 5 would be between the square root of 4 and the square root of 9. It's closer to the square root of 4, so it's probably about 2.1, 2.2. And I'm going to multiply that by 4, which would be 4 times 2.2. That's 8.8. So 8.8 is actually bigger than the side of 8. So the two smaller sides here are 4 and 8. You're not always going to get the side lengths in order from smallest to biggest. So when I do the Pythagorean theorem, I need to say 4 squared plus 8 squared. Will that equal my 4 root 5 squared? And again, we should put parentheses on there so we don't accidentally just square the square root. 4 squared is 16, 8 squared is 64, and 4 root 5 would be 16 times 5, which is 80. 16 plus 64 is 80, so this works out to be true. So yeah, this is also going to be a right triangle. So be careful with the side lengths, but the main lesson is if the Pythagorean theorem works, then it's a right triangle. We can go one step further though. If that hypotenuse squared by itself is smaller than the other two combined, then it's going to be an acute triangle. And if that c squared, or that hypotenuse squared by itself, is bigger than the other two, then it's so long that it's forcing that angle to be bigger than 90 and be an obtuse triangle. So it's similar ideas. Less than will be an acute, and greater than, the two legs combined, will be obtuse. So let's look at a couple examples of that on the next page. Determine the following lengths will make sides of a triangle, and if they do, will it be acute, right, or obtuse? That's our question. So part A, probably the best question here, 2 plus 3 is 5, which is not bigger than 5. This is not even going to be a triangle. So don't forget to ask that question first. Now on the second one, again, to check to see if it's a triangle, I've got to add the two smaller sides, which are root 2 and root 3. Root 2 is about 1.4, root 3 is about 1.7, and root 5 is probably about 2.2. 1.4 plus 1.7 will be over 3, so it is going to make a triangle because that's bigger than 2.2. So what I need to check is the Pythagorean theorem. Always start with right triangle first. Is root 2 squared plus root 3 squared going to equal that root 5 squared? Well, when you square a square root like that, it's just going to eliminate that or undo the operation. So this is like 2 plus 3 equals 5. Well, that does work. If it works, this is a right triangle. On part C, 5, root 19, and root 26, again, I need to estimate these square roots to see if it even makes a triangle. Root 19 is between root 16 and 25, so it's probably about 4.5 or so. Root 26 is slightly higher than root 25, so that's probably about 5.1, 5.2. So it's still the biggest side, so my two smaller legs would be 5 and root 19. So those are the ones that get added together. Does that equal the square root of 26 squared? So I've got 25 plus the square root of 19 squared would be 19. Square root of 26 squared would be 26. 25 plus 19 would be 44, which does not equal 26. So here is where we're going to say, oh, sorry, you haven't been able to see that. Here's where we're going to say, since the hypotenuse by itself, so 26 was the hypotenuse, since that is smaller than the other two sides combined, this is an acute triangle because smaller than 90 is acute. So that's how we decide. Let's do one more. Part D, 4, 6, and root 10. Root 10 would be approximately 3.1 probably, which is smaller than the 6. But the 4 and the 3.1 would add up to more than 6, so it will make a triangle. So we're going to say 4 squared plus the root 10 squared, is that equal to the 6 squared? So we get 16 plus 10 equals 36. 26 does not equal 36. But here's an example of the hypotenuse by itself being bigger, so it's bigger than the two combined, which is going to make this triangle obtuse. And that's the whole lesson here. I give you 3 side lengths, you tell me if it's going to be an acute, obtuse, or right triangle, or not even a triangle at all. So try the rest of the examples from your workbook and see me if you have any questions. Good luck.